what I'd like to do is take about the first 5 or 10 minutes and have you folks pair up, and you're going to interview your partner. You need to get their name and what their major is and their career goal, and then what kind of math that person needs to achieve their degree. Okay, so let's go ahead and start. I'm introducing Gina, and her major right now is undecided, but she's thinking about art and English. And the math that's needed, she eventually needs to get to transfer math, so building up. So what a lot of us come into, myself included, coming into community college, go ahead and start with building our skills, and then eventually working our way up to transfer level math.
This is Eric, and he is an architect major, and he needs Calc 3.
Okay, cool.
This is Tanner, and his major is business. He wants to get a BA in business law.
Yeah, for business law, you might have to go through business calculus. So somewhere around in there, and some accounting as well, probably. Yep.
This is Erica, and she wants to major in international business.
Yeah, for international business, if you go on for your bachelor's degree, then you'll go through business calculus. But don't let that scare you. It's just one step after the other, and eventually you're there.
This is Brandy. Her major is AA in criminology.
Ooh, right on.
Her career goal is to work in a prison. And her highest math, we think, is 123.
Yeah. Okay, so I think we've established that pretty much everybody in here is going to be having to take some math at some point. I want to give you just a pinch more of my background before I start talking about studying smarter and not harder, so I'm kind of hogging the floor a little bit. But, name, major, and career goal. But just to let you know, as far as major goes, I'm a community college student myself. And I was originally going to be a geology major because I really like rocks. In fact, my husband and I met rock climbing. And I decided not to because it took a year of calculus. And I figured that I was no good with math because I had taken beginning algebra as a freshman, and my girlfriend and I bullied the history teacher who was teaching the elementary algebra class, who knew no algebra whatsoever. We kind of bullied him into giving us an A, and we knew nothing. And anybody in here taken a math class from the water polo coach or anything like that? Okay, usually in my regular classes, that I have one or two people who's definitely had a math class from somebody who's not a math teacher. Anyway, and then I waited till my senior year. I had a kind of wild route and dropped out of high school and then came back and whatever. And so my senior year, I ended up taking the next class. Well, that had been 2 full years, kind of squirrely years, intervening in there. And so then I took it from a guy who's a great World War II fighter pilot, this guy. So told great stories, and that's about all he did. And so I couldn't do math in that, even though I tried really hard, and I'd done well in my other classes whenever I tried hard. So I thought it was me. I thought, I can't do math. Math is, whatever. Not my field. And so I carried that into community college, and I signed up for a class that was way too high for me. It would be the equivalent of math 242. Thinking, because I checked the box that I was ready for it. I had Algebra 2 in high school, so I'm ready for the next class. Well, not at all. It's like a language. You need to know the foundation before you can move to the next class. So I went ahead and I took that for, 2 weeks. And a lot of what I'm writing here, I would be writing to my younger self, saying, this is why you weren't successful. These were the things that you were having trouble with. So I took some time off, and I worked as a nurse's aide, actually, and that really helped me to grow up quite a bit, having people die that you're taking care of, not because I was taking care of them, but anyway, but that I was taking care of. One would hope not. And just there's a lot of things that really mature you after high school. And so I came back into the community college, and I began at intermediate algebra while I was waiting to get into the nursing program. I'd already had anatomy and physiology and microbiology, and those had really matured me as a student because those are pretty rigorous classes. So I took intermediate algebra, it's like our math 127, and all the lights went on. But I thought it was the instructor, so he's just a good teacher. And so I took trig and college algebra, well, it's like pre-calculus, that summer, and then I began calculus in the fall, and 4 years later I had a degree with high honors from UCLA. And I say the high honors not to go, rah, rah, I was so good. It's just to show you can start with thinking you can't even do math go all the way through to all of a sudden having a change. A lot of us were not ready in high school to learn math. And so a lot of people who weren't successful, they come here and all of a sudden they find out that they can do it. But you have to kind of get over that hump. And also building your foundational skills is key. The fact that I took a step back and didn't try to go to the next level of class was huge, a huge part of why I was successful. Also finding an instructor who kind of spoke my language was part of it too, somebody I could really understand. Okay, that being said, what I wanted to go ahead and talk to you folks about today was ways of studying. Now, this kind of assumes that you're already working hard. One of the biggest things, you guys, probably everybody in here knows somebody who can just sit back, cross their arms, and sit in the back row and just get A's on every test, and they don't seem to lift a pencil. We've all run into someone. I happen to have a brother who's like that. He's just brilliant, and he can just do it, and he didn't have to study as hard as I did. I found I had to study, and luckily I got the payoff, but learning how to study was a big part of that. But I've always had to study. I never had to, every now and then I'd back off thinking I was working too hard, and I'd get slammed, and then I'd, start studying harder again. And so, so for me personally, I've always had to study, and I would say that's true for 95%. Everybody kind of hits their wall too. I teach all the way through differential equations, and some people hit their wall in, I always had to study. Some people don't have to study till they get to calculus. Some people actually kind of float through calculus, and then they get to differential equations, and all of a sudden they hit that wall. So everybody hits it at some point. Einstein probably hit it at some point. Apparently he wasn't that good of a student, but he was obviously brilliant. So, so everybody's got to actually put some work in at some point. Assuming that you're putting the work in, this is a scenario that happens on a fairly regular basis, the first part of it, where it says familiar scenario, a student in Math 123, which would be our Algebra 1, introductory algebra, did all the homework and studied for the exam and failed the test. Okay, and so the student was understandably very discouraged. This happens to me a lot. And so then I have people, and they're really discouraged because it's not that they didn't work, they worked very hard. And so the question is what was it that went wrong with how they studied and also their perception that they knew it well enough to get it out on the test? So provided you're already working that hard, the biggest thing with math is that it's not just, people think math is like you've got it and then it's there, and it's not true. We're not hardwired to retain math. My husband, who's an engineer, he's also dyslexic, so he was one of those kids who was told, oh, you're not going to, just forget it, you're going to be, flipping burgers your whole life, so don't even think about going to college. So he got past that, and he got a degree in electronics engineering from Cal Poly. But even he says that, even though he's really gifted with math, he said it's like when you're camping and the river's down there and you have a leaky bucket, and you fill up your bucket and you run to camp and try to get as much water back there as possible. That's what studying math is like, because we're not really hardwired to retain it. What we are hardwired to retain is story. So as much as you can kind of make little stories and little cheesy sayings or whatever, I do that all the time. I really personalize the math when I'm learning it to try to memorize. People think there's not a lot of memorization in math like there is in chemistry, biology. I think we have a biology person. Huge amount of memorization in biology, and obviously music, acting, a lot of memorization in those fields as well. But math people think, oh, I don't have to memorize. Well, actually you do. You have to memorize a process as well as sometimes some formulas, but mostly it's the process you're trying to memorize. So what you've got are two parts to studying math. You've got the practice part, and that's doing the homework. But then you've got the review, and this is where the memorization really comes in. And so this is the studying for the exam, study for exam. And this is where people get really discouraged because they will do their homework and they'll do it beautifully, but it's two parts of practice to one part of review. So you can figure if you did this, it's 2 out of 3. That's about 67%, and that's about what you'd get on the test. So it's only 2/3 of what you need to do to actually pull it together. Also, the manner in which you review makes a big difference as well, because a lot of people rely too heavily on their notes, and they end up with their with not really forcing themselves to remember. So as far as strategies go then, so this is all summarized here, so I don't want to just read it to you, but I do want to kind of flesh this out a little bit and give you some ideas. Half the battle with math is organization. And really, now, you science folks, you engineering people and all of that we have, you folks are going to have to know math as a tool. You will wrench on things using math as part of your career as an engineer. But most of us, no, not so much. So why are you having to study? Part of it is to clean up your mind and the way you organize your information and the way you think. It really will kind of change the way you think. I watched this as, going from that intermediate algebra class when I was in college. I found myself thinking differently in my English class, thinking differently about a lot of different things. So it just changes the way that your mind works. And part of it is it just cleans up the organization. I was really scattered, and I can still be pretty scattered, but I'm not nearly as much as I was before I started studying math. So it organizes your mind. And so what you want to do is you want to practice good organizational skills when you're actually studying. And so one thing I'll have students, they'll come and show me their work, and they grab a notebook. They go, oh no, that's let me see. There's some math in here, but wait, no, I think it's over in this other one. And they'll grab their other notebook, and they're flipping through all over the place. So now they're already working hard, right? They already got the notebook. They're taking the notes, but they've got them all over the map. So organize everything. Have one designated math notebook where everything lives that's related to your mathematics. So that's part of the battle, is just putting that stuff together. Keep your notes and your homework separate from each other, okay? Because those are the two different things that you're going to be working with. And then for each homework assignment, you want to have this really neat, there's just like a story, there's a beginning, middle, and an end. The beginning is writing down what the assignment is. The middle is working through that. And the end is to make sure you've checked everything and everything is nicely done and finished and correct. So that's the thing with that. With the homework strategy, one thing I see people do a lot of, they're doing hard work. Again, this is working hard, but they're not working smart because they're trying to save paper. And folks, I'm all for being as careful with the environment as we possibly can, but the reality is math takes a lot of paper and a lot of pencil. And so you want to give yourself a lot of room to think. I had a really talented student, he was an environmental biology major actually. He was in my second semester of calculus, and he came to me after a test and kind of put the test down. He goes, you didn't give me enough room on these problems to think. So it's like, what do you mean? You can think. Think happens in your brain and the paper happens here. But I got what he said, what he meant. The problems, I had not left enough space for him to organize his thinking to be able to work through. Anyway, so he helped me to make my tests a little bit better, and he was stellar A at the end of the course. But telling me that was a good heads up. He needed more space. I need to give the space. You need to be a little aggressive about that, right? So you've got this test from an instructor like me who, didn't give you enough room. Get a piece of paper out or ask your instructor, do you have some scratch paper? I need more space. Give yourself enough space to actually work the problems out. And then when you're doing your homework, a lot of times people will just dive right in. They'll go ahead and they'll say, well, there's the problem, now I'm starting to solve it. You want to write the original problem down, and you want to write the instructions down that go with that problem, because that will help you to start connect the words and the math. And the higher up you go, for those of you who are going on to calculus, which is quite a number of you, but even if you're going to be taking your beginning algebra class and that's the end of the story, getting the words tied to the math is a huge piece. And the higher up you go, the more it becomes. Until, for some of you, like social science majors, you guys are going to end up in statistics where it's all about the words. And so you've got to really kind of get those two things linked together. Okay, so write down the instructions for the problem as well as what the original problem is. And then make sure you check your answer. A lot of people do gorgeous work, and then I'll look through and kind of spot check the answers and go, oh, whoa, this answer's wrong, this answer's wrong, this answer's wrong. So that's like going out to the rifle range and shooting a shotgun in the dark. It's like, did I hit the target? I don't know. You have no idea if you're not checking your answers whether you're actually thinking through the problems correctly. So check your answers. And one of my students just gave me a tip this semester. He actually Xeroxes the answers out of the back of the book and just keeps them right there as he's solving his homework problem, so he doesn't have to keep flipping back and forth. Or just put a little paper clip there. That works as well. And then if the answer is incorrect, try to find your error and fix it. But here's an important piece of advice, and every instructor gets frustrated by this because I want people to be successful on their exams. So what happens is that people will, like on an exam, they'll solve a problem, and then they'll second guess, and they'll erase the whole thing, and then they'll solve it again, and then they'll erase that, and then they'll just leave it blank. and I look at that kind of ghost of what they did before, because I can kind of see through the eraser marks and go, oh, they did it right, or they just had one little sign error in there. And so what the bottom line is with math, you don't want to erase your work. You want to make sure that you keep it. It's a gold mine, and then you just redo it. Now, if you've got one little error, you multiplied 2 and 3 and got 5 instead of 6. Okay, so that's a little error. You erase that, no worries. But if you solved a problem all the way through and you look and you can't find your error, don't erase that. Leave it there. Save yourself some work, as far as that goes too. Go over here and solve it again, and then you can kind of compare the two and go, oh, this is where I'm having trouble. I'm not distributing. So you can see the difference. Also, if you bring that to your instructor to go, what the heck, how come I'm getting this wrong? Then they can go ahead and trace through your work and go, oh, right here, right there, you made some tiny little error. Then you know that you're basically on the right track, but you just need to be a little more careful with some particular things. So don't erase your error, unless it's a little tiny error. Just lightly line it through and go at it again, that sort of thing. Especially like with word problems that are so much writing, you don't want to erase with that. Okay, if you can't find your error, erase it and then don't erase it and then try to redo the problem. But if you're still stuck, this is another thing. Sometimes people know that there was somewhere they had trouble in the homework and they can't find it. They're flipping through their homework going, I know it's in here somewhere. Get a highlighter, circle it, and you can even write, question marks by that, or say, how come this happened right here? You can put notations by that as well. So that can be really helpful. Okay, so that's 2/3 of it right there. Organization and homework, how you do your homework is huge. All right. So doing your homework really kind of thoughtfully, not just doing it for the points to hand it in. And again, this is assuming that you're starting from the standpoint that you really want to be successful with it. So sometimes people aren't ready for math yet. I wasn't in high school. A lot of people aren't ready when they first come to college. They need to do some things they enjoy first and kind of get inspired, and then they go, okay, now I need to get through with the math. So it's funny because being a math teacher, you would think I would say, yeah, take your math right off the bat. If you were my children, I would tell you, don't take your math right away unless you're ready to work at it. Okay, if you're ready to work, that's fine. But if you're still kind of waffling about and you don't know what you want to do and you're trying to find out what's interesting to you, take those classes that are interesting until you can go ahead and build up enough interest to go, okay, well, now I'll do the math. It's going to be a lot of work, and it is, but I want to be an architect, or I want to be an engineer or whatever. I want to be a nurse, so I've got, I know I've got this math I've got to do, as opposed to not being quite sure what you want to do and the motivation isn't quite there yet. So there's that, your practice, 2/3 of it. The other 1/3 then is the review and the studying for the test. The biggest thing I can say here is don't peek. You want to take your review problems. So pretty much your instructors are going to assign, until you get to some of those higher level classes, then they expect you to kind of figure out your own review problems. But when you first start out, like in Algebra 1, Algebra 2, even usually the pre-calculus level math classes, they'll give you review problems out of the textbook. So the biggest problem that, again, I'll have people studying really hard, and they're doing their work, and they did all of this, they did a great job, beautiful homework, handed in, it's flawless. They did all the review problems, and they still failed the tests. The first question I ask them is, did you look at your notes when you did your review problems? And invariably, I would say 90% of the time people go, oh yeah, I did. And they didn't think they were doing anything incorrect, and it's not wrong, it's just that it's not effective. So they did all the hard studying, but the smart studying is to go ahead and do these review problems without looking, don't peek. So you treat these like a test. Now, when you treat them like a test, you're going to have kind of a little hair rise on the back of your neck when you go, oh, shoot, I thought I remembered how to do this. Well, what you do is you treat it like a test. You skip that problem that you don't remember how to do, and you go on and you see if the other problems kind of jog your memory. If they don't, no worries. You still want to go back and go, okay, that problem I can't figure out. You mark it, you highlight it and say, this is a trouble problem for me. And you go back in your notes and you review, okay, how do I do this? All right, I'm peeking now. So I go ahead and I do the problem. And then at the end of it, I go ahead and I go, okay, so I got it. Now let me see if I could do it without looking at my notes. And moreover, I'm going to go find some extra problems that are similar. And I'm going to do those until I can do them all without peeking. Okay, so it's no more extra work than it would have been if you looked at your notes in the first place, because but what you do is you force yourself to remember, and if you can't remember, then you know that that's going to be a problem, and it'll be a problem on the test, so then you go back and you review until you can remember. Then what you do all these review problems, and then you redo them, and I don't mean with pencil and paper. Okay, this is the smart. This part is easy. It's not hard. You redo them mentally. So what you do is you have beautiful homework. Okay, you've done your review problems. They're all ready to go. Then what you do is you just take your hand or a piece of paper. And so I have my review problem is, solve 2 times x plus 1 minus 3x equals 5. Okay, so I've got something like this. And so I've done my review, so I go ahead and I go, okay, so la la la, la la la, la la la, and I have my answer at the end, x equals 1 or whatever, so I've done all my work. So this is my review, so I reviewed and I feel really good about it. But now what I do is I go through my review page and I start here, and this is why it's important to write the instructions, not just the problem, so I know what I'm being asked to do. And I cover this up. And then I go, okay, so I'm given this problem. What am I going to do? Well, I'm going to take that 2 and I'm going to distribute it, and then I'm going to combine like terms, and then I'm going to start moving stuff around, and eventually I'll get x by itself. And then you uncover and you go, yep, that's what I did. Or you say, oops, I didn't remember how to do it, or I thought it was another kind of problem that I was supposed to do something else. So that's studying smart, because it's so easy. All you have to do is cover it up and kind of think, dum-da-dum, what would I do? And then you're remembering what sorts of processes go with what sorts of problems. So that's a real easy thing to do. Whereas if you actually redid them with pencil and paper, it would be a lot more work, and you actually wouldn't get the same good out of it, because you would be still kind of in the details. This part's all about the details, the practice, but the review is not. The review is all about the big picture, which is recognizing the problems and knowing what to do. So as long as you've done the details already, then you'll have the big picture down. Okay, so this is really, more than anything else, this is one of the smart things. A lot of this other stuff, it's still hard. Math is hard work. When I took elective classes like my upper division classes where you can take whatever just to fulfill your requirements of a certain number of units, I took anthropology and philosophy and those sorts of things. I tended not to take math classes as extra. I was already taking a lot of math, and they're hard work. And so when I wanted to have just an enjoyable class, I would take a history class or an art class or something like that. And so math, I don't care how good you are with it, it's hard work. So you want to minimize that hard work as much as possible by being smart about how you do it. Okay, and then let's see. So that's all the suggestions on the review strategies. And then the second thing on your paper tells you how to go ahead and organize your review, how to get the most out of it. And then it's that covering up and asking yourself, how would I do this problem? And then checking to see if you're doing it right. And you keep doing that, cover up, mentally say, what would I do? Look to see if that you would do that. So that's what my tips would be on going ahead. Now there's lots of other stuff. So sometimes when I have people who don't do well on a test, even though they've put a lot of work into it, one other thing we look for learning disabilities or learning differences. Like I said, my husband's dyslexic, so I'm pretty tuned into that. I have some students who have a lot of anxiety or they have ADD in the class, so they hear somebody cough and their attention is scattered. There's a lot of other things that can play into it as well. But this is like the first run of analysis. You're doing all the work and you're doing it effectively and you're doing it in a smart manner. Once all those bases are covered, then you can start looking for other things that can be factors. And as a teacher, I'm able to find, because of having a lot of experience with different types of learners and different types of students, we can kind of do a diagnostic of what that is. And feel free to talk to me, talk to your instructor if you're taking a math class. Talk to Marie Larson, who's our division chair in math, who's just a wonderful. She has a son with cerebral palsy, so who's acing calculus right now. But he's really and he's actually been in the choir and sung, and this is somebody who has speech is a real challenge for. So, she's really very, very tuned into people who have learning differences and have challenges that they have to overcome. So in the math division, if you're stuck, don't ever feel like you're just, out of luck. There's a lot of support here, both from the instructors, with the math lab, and all of that. But you've got to want it. That's the most important thing, I think. So once you want it, then the support is totally there to get you through that. And getting to the point where you want it a lot of times means kind of exploring and finding what you want to do. Okay, do you guys have any questions for me before? Yes?
I have a little, you said don't peek, but then you said when you review it, you cover it up.
Yeah. So don't peek means when you're doing your first round. So when you're doing your first round, so here you go. Here your instructor has said, okay, we're going to have a chapter 1 test. And so they give you some problems and it's chapter 1 review. Okay, so you write down the first problem. The first problem says to go ahead and solve 2x plus 1 equals 5x minus 4, something like that. So you write that down, and then you close the book, you close your notes, and you go ahead and you attempt to do this problem. So attempt to solve. And usually if you've done all that work with the practice, you'll look at that and you'll go, I know what to do, and I'm good. So this is the point where you don't peek. So don't peek right here. So you attempt to solve without peeking. Then you get to the point where you get your answer, and you go ahead and box it. And then you check. And then you go ahead and you say, okay, well, how did I do, sort of thing. Now, if you hit a problem that's more complicated, so the same sort of thing, chapter 1 test, let's suppose problem number 2 is like 1/2 x minus 5/3, and everybody's starting to go, ooh, yuck, help. Okay, x plus 7. Okay, so you something like that, and you look and you go, whoa, okay, I remember doing ones like that, but I don't remember what to do. This is where I'm talking about don't peek. So what you would do is you'd leave it. Leave it for now. And you continue on and you solve some other stuff. And this is mimicking what you do on a test. So if you're on a test and you hit a hard problem, you don't just sit there and stare at it with your eyes wide open and go, oh my gosh, I can't do this problem. Because that is the feeling. You kind of get that panic. But what you do is you go, okay, fine, I can't do the problem. I'll just go on to some other problems. So you're mimicking it like a test, and you leave space to do it. Again, this is still the point at which we don't peek. Oops, I'm going to do. So don't peek. All right, so then if you can't remember, that's the point at which you trot out the notes and you look at your old homework. You find problems that are like that in the old homework. But this constitutes peeking. You have now peeked. So this is peeking. And once you've done that, now you go ahead and you go, okay, so I'm not very strong, so I better go find some more of these guys to practice until I can do them without looking at my notes. Then that's the first round. Now, after we've done all of that, that's where we go ahead and we go do that cover-up business. And so then you would look at this. You don't resolve it because it's enough work doing it the first time. But what you do is you cover up your work that you finally got by peeking. And you go ahead and you cover it up and you go, okay, now what would I do here? In this case, you'd find the LCD and multiply and blah, blah, blah. So, but you look at it and you go, okay, so what would I do? Okay, I think I remember doing, okay, and then I do that, and then you look and you go, yes. That's what I was supposed to do. Or you go, oops, no, that wasn't what I was supposed to do. So cover it back up and think again, okay, what would I do with this problem? And that's what I mean by the, yeah. So thank you for asking for that clarification. Other questions?
Can you think of any things that might affect your ability to organize?
That's a really good question. One of the things, so engineering is where you're headed. Engineering is all about organization, and one of the things that will happen naturally as you take your courses is that you're going to find yourself, just kind of because the processes that you do become so similar after a while that you just naturally organize things in a particular way. So part of it's experience, just going ahead and going through these classes. One of the things I would say is make sure you're working off of lined paper. And really try to adhere to the lines. And like when I'm tired, for instance, I start getting, you can see my writing right now, because I'm a little tired, is a bit sloppy. Okay, when I'm really thinking, okay, I really need to be careful about what I'm doing, then I really adhere to these lines and I make myself slow down a little bit. I've known people that were really good math people who could kind of be all swirly all over the place, but they're very, very rare. So mostly, like for instance, so if you're asked to go ahead and solve, or let's just do something that's an arithmetic problem because people can do that. So you're asked to go ahead and simplify something. Let's suppose you had 2 times 3 minus 2 times 5 plus 1 or something like that. So what a lot of times people will do with something like this is they'll go ahead and they'll go, okay, well 2 times 3 is 6, and then I've got minus, and then I've got this business, which is 10, but actually I'm adding 1 to it, so that's going to be 11, and now I've got 6, and so that's minus this guy right here, and so that's going to be equal to -5, and then there's their answer. So that's an example of something that is just like crazy, crazy unorganized. And with arithmetic, a lot of times you're so focused on the answer that you don't really care how you organize it. But as soon as you get into algebra, you really have to go, it's called line by line. And you're just really slowly working through going, okay, well, I'm going to multiply, and then minus, I have these parentheses, so I have 10 plus 1. But I have to recopy. One thing with math, there's a lot of recopying that happens. So if I don't touch something, like notice I didn't touch this minus right here, so I have to recopy that minus in order to go ahead and put it there for reference. Notice I didn't use the parentheses up yet because I'm still grouping these things together. So I multiplied this. This plus 1 tags right along for the ride. I didn't do it yet, because I wasn't ready to. There's other things that needed to happen first. So I recopy, and I recopy the parentheses. So being very meticulous about recopying is part of the organization that really helps with that. And then again, another really nice strong line. Okay, so 6, and then minus, and then this is going to be 11. And so that sort of thing where you're recopying stuff, and you've got this real strong, things going in a very nice line sort of fashion. So using line paper, a lot of engineers actually use that engineering paper. It's kind of expensive, but eventually your engineering instructors will require it. It's the ones with it's the green paper with the little grids on it. So that's a very nice structured paper that you can use, but at least having lines. And this would work out to be -5 when all is said and done. And part of it is slowing down. When I get going fast, as you can see, I talk really fast and I can write. Boy, when we used to have chalkboards, my students told me I made the chalk smoke. And I had to really learn to slow down a little bit. And so that's really important to just slow down and take your time. So that's part of the organizational skill too, definitely. And then having your instructor check. Like go sit down with your instructor and say, look, this is how I'm doing this. Does this look well organized to you? And then having him or her give you some feedback on that. It's a really good thing as well. And they might look and go, this is beautiful. Or they might go, well, you could kind of clean it up right here and give you some tips on that. So good question. Other questions on that? Okay, I want some feedback from you guys. So I'm going to send this around. This is my first time doing one of these workshops, and I was really excited to get in here to get a chance, because I don't get to do this in my regular class. We talk about it a little bit, but mostly I'm teaching the math. So I'd like to do some more of these in the future, and so it would really be helpful if you told me what's working for you and what you would have rather heard if there would have been something better. So be brutally honest and let me know what you think.
Thank you, Peggy. Let's give her a round.